Good afternoon to all. Today we are discussing the important part of the chapter called as fertilization changes, how that takes place in angiosperms. In the last class we have seen the topic pollination and the different types of pollination, and pollen grains are now rated on the stigma. I will revise once again to the structure of pollen grain or male gametophyte for this purpose. We have seen that pollen grain or male gametophyte have this kind of structure, indine exile, and inside there are one large vegetative cell and a small generative cell, and this is called pollen grain, and we have seen the structure. And in many plants pollen grains are having two-celled condition. In some other angiosperms, the generative cell, the small cell is called generative cell, as you know. Generative cell divide into two male nuclei. See, contain two male nuclei. Generative cell contain two male nuclei. So this is the structure of male gametophyte or matured pollen grain in angiosperms. So there are two male nuclei are present in one male gametophyte or pollen grain. See, you have seen the structure of female gametophyte. So the structure is called female gametophyte or mature ovule, having this structure, and this is called anatropous ovule. The tissue is called nucellus, and inside there is an embryo sac. Inside there is an embryo sac. The structure is called, the stalk is called funiculus. The point where the funiculus join with the nucellus or ovule is called as hilum, and the opposite end there is an opening called micropyle, and this end of the ovule is called micropylar end. The opposite end is called chalazal end. The end is called chalazal end. So see that the opening is called micropyle. This end of the ovule with micropyle is called micropylar end, and the opposite side is called chalazal end. And the point where the funiculus join with the nucellus or ovule is called hilum. And there is a structure called, covering is called integument. The covering is called integument. The tissue is called, inside is called nucellus. And inside this structure is called, inside this structure is called embryo sac. The structure is called embryo sac, and this embryo sac, as you know, it is a 7-celled 8-nucleated structure. Inside there is a central large cell. This central large cell is called egg cell or female gamete. On either side, two cells are there. The cells on either side are called as synergid. It is called as synergid. And on the chalazal end, on the opposite side, chalazal end, this side contain three cells called as antipodal cells. Antipodal or antipodal cells. At the middle region, two nuclei are present, haploid. These two nuclei are now called as polar nuclei. So this is the diagram of female gametophyte in angiosperms. So remember that this is a female gametophyte. Female gametophyte means the gamete containing structure, the embryo sac. This embryo sac is otherwise called as this structure. This embryo sac is called as female gametophyte. You know the name gametophyte. Gametes containing structure is of gametophyte. This is the male gametophyte in angiosperm. Male gametophyte and female gametophyte. Male gametophyte. And this is a female gametophyte because it is a gamete containing structure. and we can draw the separate embryo sac. I will draw later on. I will give the difference between ovule and female. Anyhow, female gametophyte. So this is the female gamete containing structure called as gametophyte. This is the female gamete or egg cell. These two male gametes are there. There is only one female gamete. So this is the structure of male gametophyte, pollen grain, male gametophyte, and this is the female gametophyte, mature female gametophyte. So here the two male gametes are there, one female gamete is there. So this is the structure, and this just I am given for remembering or revising once again, because I have to explain today how the fertilization takes place. I will that is clear for you. See, next comes the, so we have seen the how pollination takes place. The pollen grains are transferred from anther to stigma, and pollen grains are reaching on the stigma. Stigma is the receptive part of the pollen grain. Stigma receive pollen grain. So I can present again the stigma. The tip is called stigma. The base is called style. Sorry, the nucleic part is called style, and the basal part is called stigma. Sorry, round ovary. So this is the structure of ovary, and here this is the structure of gynoecium, and inside the gynoecium I represent the ovule like that. See, this is the female gametophyte. The covering is called nucellus, and tissue is called nucellus, and there is the micropyle like that. Micropyle, and here is the micropyle, and there is the central large egg cell, and there are two synovids are there. At the middle there are two polar nuclei. On other side there are three antipodal cells are there. This is the structure of. Now the pollen grains are on the stigmatic surface. Just I started that in the last class. Pollen grains are present on the stigma. Numerous pollen grains may reach on the stigma. Different types of pollen grains may come. Of the different plants may come, because may be carried by wind or insect or like that. The different types of pollen grains will reach on the stigma. These all structures, pollen grains, the stigma secrete a sugar-like substance. Stigma produce a gum-like substance at the tip. A honey-like secretion is produced at the tip of the stigma on the day of opening of the flower. So all the pollen grains are falling on the sugar-like secretion or honey-like secretion at the tip of the stigma. Then the stigma identify the right type of pollen grain and wrong type of pollen grain. If the pollen grains are coming from some other plants or some other species, it cannot germinate or it cannot fertilize. So the stigma identify right type of pollen grains and avoid wrong type of pollen grains. You see that this honey-like secretion contain different types of hormones are there, enzymes are there, calcium and boron-like metals are there. So this enzyme or this hormone react with chemical reaction takes place between the stigma and pollen grain, and these chemical reactions are mediated by hormones or enzymes. So continuous chemical reaction takes place between the pollen grain and the sugar-like secretion, honey-like secretion, and that chemical reactions are mediated by, controlled by enzymes present here, hormones present here. And by the chemical reaction, interaction between stigma and pollen grain, wrong type of pollen grains are avoided and right type of pollen grains are selected. So right type of pollen grains are selected and wrong type of pollen grains are avoided. And if the selected pollen grain began to germinate, the selected pollen grain, its own type of pollen grain, same type of pollen grain began to germinate. Like a seed, you see that when the seed germinate, a small tube-like structure will come out. You have seen that the small tube-like structure is called as radicle, and one come towards upper side. That tube-like structure is called plumule. This is called germination, seed germination. Similarly, the pollen grains began to germinate. See how the germination takes place. During pollen germination, pollen grains, coverings, and on the egg side, numerous small openings are present. That openings are called germ pore. Germ pore is there. A small opening is there. You have seen the structure of pollen grain. The small opening called germ pore. Egg sign is thin or absent. To that, this pollen grain is absorbed sugar-like structures, and this pollen grain began to germinate. During germination, the indine grow out into a tube-like structure. The indine grow into this tube-like structure, a tube-like structure. This tube-like structure is called as pollen tube or germ tube. This indine grow into a tube-like structure called germ tube or pollen tube. And the contents of the pollen grain, you see inside there are 3 nuclei are there, cytoplasm is there. First of all, the vegetative nucleus comes. Vegetative nucleus somewhat larger, and vegetative nucleus comes first. Behind that, 2 male nuclei, not male gamete, male nuclei enter into the pollen tube, and all the cytoplasm enter into the pollen tube. Cytoplasm and the 3 nuclei enter into the pollen tube. First, vegetative nucleus come, then 2 male nuclei enter into the pollen tube, and the complete cytoplasm etc. enter into the pollen tube. So there is nothing is completely empty. All the contents enter into the pollen tube or germ tube. And the pollen tube, tip of the pollen tube produce enzymes. Tip of the pollen tube produce digestive enzymes like cellulase and pectinase. See, it produce cellulase and pectinate-like enzymes are produced by the tip of the pollen tube, and the pollen tube grow downwards. See, this pollen tube grow downwards into the style. To grow downwards through the style. Tip of the pollen tube secrete enzymes. See, the tip will produce enzymes, and like digestive enzymes like cellulase pectinase, and it will digest the tissues. See, this is a tissue, not a gap structure. See, this is not an empty space. It is a gap. Parenchymal cells are there. So, by the production of enzymes, it will digest the tissues. While it is going downwards, it will digest the tissues of the style and absorb it. You see, it is a growth of the pollen tube. Growing pollen tube require food material. It has to pass downwards. So the tip produce digestive enzyme, and the enzymes will digest the tissues on the style, and the pollen tube will absorb the digested food material and use for the growth of the pollen tube. Anyhow, growth require food material, pollen tube also require food material. So the enzymes are secreted. The enzymes will digest the tissues of the style and it absorb, and finally the pollen tube grow downwards and finally reaches the micropyle. See, it grow downwards and reaches the micropyle. Near the micropyle, I represented an ovule with the micropyle at this region, and this is called as orthotropous ovule that we can discuss later on. There are 4 types of ovules are there. I represented the micropyle at this region, at the tip region like this. So this type of ovule is called orthotropous ovule, and in some plants in your textbook it is that this ovule is turned like that. So micropyle can be seen at the lower side. Such an ovule is called anatropous ovule. 4 types we can discuss after reopening of the school. So this is called for easy identification. So I am just representing like that. So the germ tube or pollen tube reaches the micropylar region, near the micropyle, with the vegetative nucleus in front and 2 male nuclei behind that, and reaches the micropylar end, and slowly it enter into the micropyle or ovule through synergid. I will represent in another diagram how it entering into the micropyle and ovule and what happens. See, I think after this is clear for you. The male gametes, sorry, the pollen tube from the stigma, it comes to the style and reaches the ovary near the micropyle. And next diagram, I will represent how the fertilization takes place. See, this is the embryo sac, into the structure like that. This pollen tube with the nuclei reach near the micropyle, and inside there is the female gamete and two synergids on either side, two polar nuclei and antipodal cells are there. So the male nuclei reaches the micropylar region and it enter into the embryo sac through the synergid. See, on either side synergids are there, and synergid, the pollen tube enter into the embryo sac through synergid, either side or through this side. Because the synergids can be represented like that. Synergid contain a structure called finger-like structures called filiform apparatus, and this synergid, both synergid contain finger-like structures called as filiform apparatus. Just you can represent like that. Suppose this is the egg cell, on either side synergids are there. This synergid contain these finger-like structures like this. Synergid contain these finger-like structures. These finger-like structures present in the synergid is called filiform apparatus, and this filiform apparatus attract the pollen tube and it guide the entry of pollen tube into the embryo sac. So this pollen tube enter into the embryo sac through synergid and it discharge the three nuclei into the embryo sac. See, three nuclei are there. This vegetative nucleus, then the two male nuclei reaches the embryo sac. See, three nuclei reaches the embryo sac, and after reaching the embryo sac, the vegetative nucleus disappear, because the role of vegetative nucleus or tube nucleus is to lead the male gametes, male nuclei into the embryo sac. So after reaching the embryo sac, the tube nucleus or vegetative nucleus disappear. See, the role of vegetative nucleus is to guide the pollen tube and deposit the two male nuclei into the embryo sac. So after doing that function, the vegetative nucleus disappear. So in the embryo sac, two male nuclei reaches. Then next process, important process called as fertilization takes place. So after that we can see how the fertilization takes place. See, then after, you remember that two male nuclei are there. One of the male nucleus join with the female gamete or egg cell. See, one male nucleus. So I represent in this diagram like that. One male nucleus join with the female gamete or egg cell. That process is called as syngamy. See, one of the male nucleus join with the female gamete. That process is called syngamy, resulting in diploid zygote. See, one of the male nucleus join with the female gamete. See, male nucleus and female gamete. Here only nucleus is, there is no cytoplasm also involved. So this is called male nucleus join with the egg cell, or female gamete. That process is called syngamy, resulting in diploid 2n zygote, diploid zygote, 2n diploid zygote. And one male nucleus is remaining here. And before next process, the two polar nuclei join together. Two polar nuclei join together. Now the resulting cell is called, nucleus is called secondary nucleus. Secondary nucleus is diploid. See, the two, now this is, which are called polar nuclei, and before the next process, the two polar nuclei joins, resulting in diploid secondary nucleus. And the remaining male nucleus join with the secondary nucleus. The process is called triple fusion. The process is called triple fusion because it involves three nuclei. You see, two polar nuclei join to form diploid secondary nucleus, and remaining the second male nucleus join with the secondary nucleus, resulting in, that process is called triple fusion because two nuclei and one nuclei, two female nuclei and one male nuclei join to form diploid secondary nucleus, and the process is called triple fusion, resulting in primary endosperm nucleus which is triploid, resulting in primary endosperm nucleus which is triploid. And this process, first joining is called syngamy, second joining is called triple fusion, and are together called double fertilization. Now, there are fertilization, two stages are there. I will revise once again. One of the male nucleus join with the egg cell, that process is called syngamy, resulting in diploid zygote, which later develop into embryo. Second male nucleus join with the secondary nucleus, that involve three nuclei, so called triple fusion, resulting in primary endosperm nucleus. I represent the pen, primary endosperm nucleus, which is triploid, which later develops into endosperm, which store food material or which is the nutritive tissue for the growing embryo. So actually, fertilization in angiosperms consists of two stages. First stage is called syngamy and second stage is called triple fusion, and these stages, two stages are together called double fertilization, which is a unique process in angiosperm. In other four groups of plant kingdom, double fertilization is absent. So this is a unique process in angiosperm. Syngamy and triple fusion are together called double fertilization, which is a unique process in angiosperm. So I will revise once again the total process of fertilization. See, pollen grains are falling on the stigma. It absorbs sugar-like pollen grains. Plant iron stigma, identify right type of pollen grain and avoid wrong type of pollen grain. Right type of pollen grain will germinate. During germination, pollen grain indent grow out into tube-like structure called germ tube or pollen tube. That grow downwards and finally it reaches the stigma, and the contents of the reaches the ovary. The contents of the pollen grain vegetate nucleus and two male nuclei enter into the pollen tube, and it reaches the micropylar end. It reaches the ovary, and here the vegetate nucleus comes first and two male nuclei come behind it, and it reaches the micropylar region. After reaching the micropylar region, the contents of the pollen or vegetate nucleus and two male nuclei as pollen tube enter into the embryo sac through the synergid attracted by controlled by the filiform apparatus, and the pollen tube enter into the embryo sac and discharge the three nuclei into the embryo sac. The vegetate nucleus disappear, the role is over. Two male nuclei remains here, and of the two male nuclei, one of the male nucleus join with the female gamete or egg cell. That process is called syngamy. Second, two polar nuclei join together to form secondary nucleus, and the second male nucleus, one male nucleus joined here, second male nucleus joined with the secondary nucleus, and that process is called triple fusion because it involves three nuclei resulting in triploid primary endosperm nucleus, which later develops into endosperm in which is a storage tissue for food for the growing embryo. This is called triple fusion. So syngamy and triple fusion are together called double fertilization, which is a unique process in angiosperm. So diagram is there. I explain the complete process and I will give the summary of fertilization. What is fertilization? The meaning is that joining of male and female gamete is called fertilization. In angiosperm, fertilization takes place by two stages. See, joining of male and female gamete is called fertilization. In angiosperm, it takes place by two stages. In the first stage, one of the male nucleus join with the egg cell or female gamete. That process is called, this process is called syngamy. The process is called syngamy, resulting in zygote, which is diploid zygote, which later develops into embryo and future plant. And second stage is that the second male nucleus join with secondary nucleus, which is diploid, this is haploid, secondary nucleus resulting in primary endosperm nucleus. I represent PEN, primary endosperm nucleus. That process is called triple fusion. That process is called triple fusion, resulting in triploid primary endosperm nucleus, because haploid plus triploid, three sets of chromosome, primary endosperm nucleus, which grow into a tissue called endosperm, storing food material for the growing embryo. So this is the product. One product is called embryo, another process is called endosperm. We got embryo, diploid embryo and triploid primary endosperm nucleus. Embryo is diploid and primary endosperm nucleus is triploid. So this process together, these processes are together called, two stages are there. The two stages are called double fertilization, which is the unique process in angiosperms. So this is the second important stage, or the main content of the chapter is fertilization. And you can study, and just written like an equation. Male nucleus, one male nucleus join with the egg cell, one male nucleus, haploid male nucleus join with the haploid egg cell, one male nucleus join with the egg cell. That process is called syngamy, resulting in zygote diploid, which later develops into embryo and a plant. And the second male nucleus join with the secondary nucleus, resulting in primary endosperm nucleus, which is triploid, and the process is called triple fusion. And the primary endosperm nucleus later develops into endosperm, which store food for the growing embryo. And the syngamy, the first stage is called syngamy, second stage is called triple fusion, and these stages are together called double fertilization. Fertilization takes place by two stages, so called double fertilization, and we can see the double fertilization in angiosperms only. In algae, bryophyte, pteridophyte and gymnosperms, there is no double fertilization, and this double fertilization is a unique process in angiosperm plants only. So this is an important part. What is double fertilization? What are the two stages of double fertilization? What are the products of double fertilization? What are the ploidy, chromosome number of resulting cell? So this is very important. Zygote is diploid, primary endosperm nucleus is triploid because it involves 3 nuclei, 2 female and 1 male nucleus. So this is the process of fertilization in angiosperms. So here the 2 products of fertilization, embryo and endosperm, zygote and the primary endosperm nucleus are the products of fertilization. Then angiosperms, how the zygote develops into embryo and primary endosperm nucleus develop into endosperm. So after fertilization, all other cells will disappear. Only this tissue, this is a product, and 2 things are remaining in the embryo sac. This is the zygote, that is diploid, and this is the primary endosperm nucleus, that is triploid. All other structures will disappear from the embryo sac. Only these 2 structures will remain in the embryo sac. That is called the zygote remains there, and primary endosperm nucleus remain in the, or the antipodals and synergids all will disappear. The function of these structures, antipodals, are not completely explained. Synergids are explained because they are guiding the pollen tube into the embryo sac because of the presence of filiform apparatus. So this is the process of fertilization. I explained twice or thrice, and in the notebook it is very clear. So you go through the process completely, and I have given the equation also. So fertilization is an important process in angiosperms that include 2 stages. So complete the notes, and then we have to see the next class. We have to see the 3rd process of reproduction, that is called post-fertilization changes. What happens after fertilization? The fertilization is over by the process, and after fertilization, what happens to zygote and what happens to primary endosperm nucleus? In the next class we can see how the post-fertilization changes takes place in angiosperms and how the process takes place. So write the notes completely and read the notes completely so that we can go to the next topic. So the remaining part of the post-fertilization change we can see the next class. Thank you.